Okay, so our first problem to start a 2-day review. We do have one new thing, actually two kind of new things today. That's basically weirder problems about long division like this one, and limits. Those are the two things that are going to kind of be new. Other than that, it's going to be a review. Then tomorrow will be a more extensive, wide-ranging review. This is going to be like slower and deeper in a few spots. All right, so I hope you started with an x squared right here. Times that makes x to the third. Times that makes plus x squared. And then who remembers what I'm supposed to do next? Yes?
Make the one with the bottom
opposite. Opposite. Drop it down, I get 5x squared. Bring this down, I get plus 1. And then that tells me I need a 5 up here. Just a 5? No, a 5x. 5x times x makes 5x squared. And then the 5x times the 1 makes plus 5x. And that's where you might have gone, what the heck? Well, remember your rules. Opposite, opposite. And can you really take minus 5x and the minus and the 1 and then like actually like put them together? No, you can't. They're not like terms. So you should have said plus 1 there. And then can you stop right there? No. Why not? Because you need one more thing on the top here to match up your negative 5x. I can put a negative 5 up there. Negative 5 times the x will make negative 5x. The negative 5 times the 1 would make negative 5. And then I do opposite, opposite, and then you'll have a remainder of 6. Who had a remainder 6? Nice. So how do you write the final answer? This and this plus the remainder. So I'm going to say x squared plus 5x minus 5 and x plus 1 plus 6. Does that ring a bell? If it was that easy, how many of you feel confident that you got this? Okay. Now, how about if I step it up a notch? How about if I say, okay, this part's just a longer problem. That's not the scary part. But would you please write out x to the third minus 13x squared plus 35x plus 49. That's not the scary part. And I'm going to tell you one of the roots, and then that shouldn't be that scary. What if I told you that I had a root was 7? I said c equals 7. That's how the homework problems usually gave them. But then last but not least, I said, oh, by the way, it's a double root. There's a double root at 7. Well, some of you were all set to just go, so x minus 7. Raise your hand if you were that far. Okay, good. Now, what if it's a double root? There's two ways you could handle this. One, you could just do it as it is. Just do it like it is. But then you'd have to do it again because x minus 7 is in there twice. So you can long divide it out twice. Or did anybody think that maybe we could do this? That's a good idea. That would have worked, but you'd have to multiply it out. So it would be x squared minus 14x plus 49. You could do that. I personally think it's easier to just do it this way. And then when you're done, you'll have to realize that x minus 7 will go in again. If it's really a double root, x minus 7 goes into it twice. All right, we'll see what happens then. Give it a shot. I'll pause for a minute while you finish. You can do it either way. In a moment, I'm going to ask you to compare with the kid next to you and see what they got and what you got and see if you got the same thing. Okay, let's see how that went. Should put an x squared here. Makes x to the third. We need to multiply that times that. That times that makes minus 7x squared. Draw the line. Opposite, opposite. After the first row was done, you should add negative 6x squared. Raise your hand if you had that one right. Excellent. Now finish it. How many of you actually are finished? Okay, that's many of you, but not all. Finish it up in a moment and then compare it to the kid next to you. If you're already both ready, then compare. So, can you just tell me the rest, Miss Pap? X squared plus. What'd you get?
For the final answer, or?
Yeah, well, like, what's next? Let's just do the one more step.
So the next step is you drop down to 35.
Thank you.
And then you're gonna wanna use a minus 6x.
You are correct, and then that's negative 6x squared, and then this is plus 42x, but then it's opposite day, and then you got, negative 7, is it?
It's,
Negative 7x?
yeah, negative 7.
Okay, and then you got the plus 49. My tip of the day was, the other day, that if those two factor, it often means that it's gonna work. Not that that helps you that much, but, okay, so now those two do factor, 7 comes out. So you go, oh, looks like I need a negative 7. And then it's negative 7x, and then minus or plus 49, and then I get opposite, 0 remainder, yay. And here's the really, really sad moment. Kid goes, x minus 7 times x squared minus 6x minus 7. And they say, yay, I've factored it and I'm done. And then they don't get credit. Zodi, why not? Isn't this the right answer?
Because you factored x minus 7 out at multiple steps.
It says that 7 is a root and that it was a double root. You remember me saying double root? Now here's another classic mistake then. They're like, oh, so I know this must be squared. And then they leave it like this. You get how they might be thinking that way? Like, oh, x minus 7 is a double root, so I'll put a squared on it. But when you multiply that out, you'd get x to the 4th. That's not x to the 3rd. So what's the missing piece here? What should I do to get the right answer? Yes?
Factor the one on the right.
Yes, if you can factor it, you should. If you forgot that, shame on you. You're supposed to be thinking about, I wonder if the answer is factor it, because it usually is. Not to say that it answers all questions, but it's the step that a lot of people forget. And this is an x minus 7 again, and an x plus 1. And there, look at that. That's how it's a double root. What was the other root? Liam? The double root was 7. What was the other root? Negative 1. We already knew that 7 was a double root. All right. Do you remember we would describe graphs like this and say, oh, it's up on the right or down on the left or that kind of thing? Remember that? Would you agree this one's called up on the right, down on the left? This is not a trick question. Do you get that that was the right answer?
Yeah.
Okay, good. Now we have a more complicated way to say this. And this is called limit notation. The Eagles sang a song, "Take it to the limit." Well, you're going to be taking this to the limit, which is the limit of the function as x approaches. Well, there's two ways to do this, the right side and the left side. So the correct answer to the Eagle song is, do you want the left-hand limit or the right-hand limit? But anyways, the right side would be x goes to infinity. Better copy this down. The limit of the function is x goes to infinity. That's the right-hand limit. I haven't said the answer yet. But it's kind of like asking this. If x goes to infinity, what does y go to? Y goes to, you're right, infinity. And right now we're just doing simple limits. This is your first introduction to a limit. And so we're not, of course, going to do complicated things. If you were in first grade and they teach you adding, you're not going to go, well, let's add polynomials. That would blow them out of the water. So our limits are going to be simple. They're going to be, answers are going to be infinity or negative infinity. We'll do more complicated limits later. All right. So if you understood what just happened there, and that this was the right end, then would you write me the left end limit? Hint, it has the word limit in it. If that was the limit for the right end of the function, what would the limit on the left end be? You have enough info. Quite a few kids were able to do it last hour. I'd like you to write lim, because of course lim is in it. Do you think f of x would be in it? Well, got to have an f of x in it. It had one last time. How about equals? Do you think you can have one of those? Yep. How about an x going to something? Yes, but do you think x is going to go to the same place? Okay, so then take your answer, compare it to the kid next to you. See if you've theorized, figured out limits yet. All right, Daniel, please read me yours. Wait. Then you start reading this part. X goes to, and that's the left end. Very good. And then it equals what? You are correct. Remember, this is the y goes to this, and the x goes to that. That makes sense? All right. Let's see if you really got this. What is the right end limit? Right end limit statement. Wouldn't it be easier to just say down? Yeah, but you're in honors pre-calc, so we got to step it up. Limits are something you're going to use in calculus a lot. That's why I feel like the first day I teach you this, I shouldn't just like do 2 seconds on it and then quit. That's one of the reasons that I felt like I should push the test. Because this is like, seriously, you're going to spend a month on different kinds of limits. And this is the first time you've ever heard of them. And I don't want you to get it wrong. Have you ever learned somebody's name wrong the first time and then like it sticks that way? Oh, your brain is good at that. Like you hear something, this new kid in the neighborhood, and you think it's Alexa, but it's actually Alex. And then like you just keep thinking Alexa over and over and over again. Okay. Did you say lim of the function as x goes to right end, it would be infinity, is equal to negative infinity? Raise your hand if you had that one right. Okay. If you didn't, make sure you understand we were going here. And what's x when you go over there? It's this way. It's positive infinity. X goes to positive infinity. And I get people look at this and they go, it's going down. How come it's not negative infinity? Because the y value is negative infinity, but the x value is how far it goes over here. Positive infinity is way to the right. X is represented here. All right. Then, if you really have got this, then I should be able to give you 2 limit statements, and you should be able to sketch what the graph looks like. The limit of f of x as x approaches negative infinity is infinity. On the other end, on the right side, the limit of the function as x approaches regular infinity, that would have to be there if I was on the right end, equals negative infinity. Would you draw a graph that goes through the origin and it has those 2 limits? Now, just to clarify, they don't always have to go through the origin, but they can give you other things like make it have a root of 6, make it have a y-intercept of 10, or make it go through the origin. All right? So make a sketch of what that would look like. There's a lot of different ways to do it, but you should know what the ends do and compare it with the kid next to you and see if your ends are doing the same thing as their ends are. Okay, here's hoping you had the left end up. Why? Because the y value of it is positive. It's a positive infinity, so it's up. And then the left end, then the right end, this signifies the right end, is going to negative infinity, so it must be really low. And there you go. That would be good enough. Here's another one that would still be right. It's all about the end values and going through 0, 0. It's got a little extra dipsy-do in there, but it doesn't hurt. Okay. Then one last limit. And I want you to theorize, even though you don't have to get tested on this, the U.S. population and the world population has been going up for a long time. Do you get that the populations of different animals, like I don't know, geese, sometimes you get a lot of geese, population of geese goes up. Why aren't we walking through 3 feet of geese? Like the geese level has gone to be 3 foot deep. There are geese everywhere. Well, they don't keep going up forever like that, right? Do you think the human population will keep going up like that forever? We hear a lot about population growth, and it has gone up a lot. If you look at the world population over a long period of time, yeah, it spiked a lot. But do you think the human population will just keep going forever? No, if so, they'd be walking all over. Humans would be 3 feet deep all over the planet. That doesn't make sense. So, one of the things that has caused our population to tail off a little bit has been population growth in certain nations has gone down dramatically, like the U.S. Did you know that in the U.S. we are not having enough babies to keep up the same population? So, as in, we need a birth rate of about 2.5 would definitely do it. 2 point something.
1.
Is it 2.1?
Yeah.
Okay, so we need 2.1 just to keep level population. Meaning that every day people die, every day people are born, and if all of a sudden one of those gets out of whack, like there's way more people being born than dying, then your country's growing. And if it goes the other way, if way more people are dying than are being born, your population will start to shrink. And that's happening in a lot of countries throughout the world. There's actually some significant drop-off. Now, does this mean I think the world population is doing this? No, but the United States population might. Believe it or not, some countries like Japan actually are going down. They're actually getting less people in Japan every year. It's not that complicated. Just don't have enough babies and then that'll happen. Because people are going to keep dying. So, if our population were to level off at let's say, right now we're at 350 million-ish. So let's say it's at 400 million, our population ends up leveling off. We just kind of stay there. Because there's enough babies being born to kind of keep it level. Immigration is a factor too. But let's say we did this. Then what's the right end limit? This is called a basic logistic function. It's actually a real function because a lot of populations do this. Like if you had fish in a tank and you kept feeding them the same amount every day, and they're allowed to there's no predator fish in there. They just little goldfish and they breed, and then eventually they're going to reach a population that's like the highest that they're going to get. Might even go up and down because it might like spike and then drop. That happens a lot in the real world. Deer population goes up a lot and then it drops because there's a lot of times a bad winter or something and a lot of deer die off. Okay, you should have said the lim of the function as x approaches, and there's an equal sign, and just to clarify, every limit you ever write will have those pieces in it. I'm going to write it darker in black because I can tell now that it's not quite dark enough to see in this bright room. Limit of the function as x approaches. They'll always have that. And then this is where you put the x value, and on the right it'll be infinity because x is infinity when you're way to the right. And in this case, our test questions so far would only have been positive or negative infinity, but this time our limit was 400 million. And I wrote 400,000 so you can be forgiven for saying 400,000, but I was just not done writing my zeros yet. The U.S. population is about 350 million, and it'll peak at about 400 million that's the theoretical graph here. I have no idea what the U.S. population will really do. Okay, cool. How many of you knew that there was a positive infinity right there? Okay, good. And then do you get that if this approaches like an asymptote line, then that's why the limit is there? Okay, all right. Then here is a big combo problem that encompasses a lot, not everything. That's one of the reasons that I felt like I can't just review today and test tomorrow. I can't get through all of it, but I can. Here's one question that if you can do this, and it's a multi-part question, okay? If you got all of these things down, then you're at least more than halfway, all right? So y equals negative x minus 2 quantity squared. You should be able to sketch this on an xy axis. You should be able to tell its left end limit, its right end limit. I'll leave space to leave my answers. And there's quite a few more. You also should be able to tell me its y-intercept, its x-intercepts, its degree, its lead term, it bounced where? Bounce? Yes, if you sketch it, and you sketch it right, you'll understand what I mean. It cut through where? There were no snakes on this one, but that's another way you can touch the x-axis. It's kind of like an x to the third does, but this doesn't have that. So let's see, your sketch, I knew right away that it went through 0, 0, and it went through 2, where x is 2, because they're the things that make the equation 0. They're the zeros, they're the x-intercepts, the roots, and the solutions to the equation. I knew that it was negative, so it had to be going down at the end. I guarantee you somebody forgot that, because it just always happens. Somebody didn't notice there was a negative in front, so it's got to be going down on the right. Then I knew it bounced at 2 because of that. That's called its multiplicity. The multiplicity was 2. It bounced there and then went back down again. And then it comes up here and it feels like it should keep going up to the left. How could I verify that it does go up to the left? I look at my degree. And my degree of this one is 2 plus, that's a 1, so it's degree 3. And degree 3s are opposite on both ends. So yay, I've drawn my sketch right. Now the left end limit. The left end, you'd say lim of f of x. And if you're going to do a left end, you say x is approaching negative infinity. That's where x is when you're on the left end. And that equals infinity. On the right end, that's over here, limit of this function as x approaches infinity. On the right, x is approaching over this way, it is infinity. So what is the y value when I get there? It's negative infinity. There was your right end limit. The y-intercept, well, it happens to be the same as one of the x-intercepts. It's 0, 0. The x-intercepts, well, the x-intercepts are where y is 0, so I'm going to put comma zeros. That's how you should put them in the Schoology Quiz today. The x-intercepts are where y is 0, and it's 0, comma 0, and it's 2, comma 0. The degree is degree 3. We talked that over before because of this, plus another 1 for that. Makes degree 3. The lead term, if I multiplied this all out, it would be negative x to the third. That's the lead term then. It's whatever would be in front if you multiplied it all the way out. Does it bounce? Yes, at 2. Does it cut through? At 0. And would I like it even better if you wrote those as points? Yes. The point would be 2, comma 0, and this would be at 0, comma 0. Okay, that answers a lot of stuff. It's not everything, but it's a good start to the review. Now, the Schoology Quiz. I have posted it. It's due tomorrow by 8, and it is in the formative part of your grade. It does count. So I strongly recommend it, not only because it'll help you do better on this for this test, because it actually counts in your grade. I give you 2 tries at it, and you'll get the answers right upon finishing it the first time. So you're not left in limbo wondering, why did I get this wrong? Okay? But if it's pretty bad the first time, you can always do it again, get an average. Okay? I'd like you to open that right now so that I can see that you have found it, because quite a few kids thought I was talking about a different Schoology Quiz. So I'm going to go and look at who is done and who is started. Remember, the settings on this are set so that you can resume it, so it's not going to hurt you to start right away. And you get 2 times with the average score. Yes, resumable. And I think that's all I got for the video for today.